guys, welcome back to the channel. My name is Jag, and in today's class we're going to continue with our Chemistry 11 content. What we're covering today is going to be within the gas laws unit, which is the last unit in Chemistry 11. And today we're going to look at Boyle's law. So in this unit, actually, all the formulas are very simple, okay? You do have to memorize the formulas. They usually are not provided, okay, on the unit test or the final exam. So I'm going to write down the law for Boyle's law. So Boyle's law is basically P1V1 equals P2V2, okay? Now P1 and V1 are going to be the initial pressure and the volume, okay, of the gas. So maybe let's just make a quick note here. So P1V1, I'm going to put initial pressure, okay, and volume, okay, of the gas. And that's going to be equal to P2V2, and these are going to equal to, this is the final, okay, pressure and volume, okay, of the gas. And you can see that the formula is very simple, but I always write down what is given to me in the question and what am I required to actually find, okay? So with that, let's try an example here. I'm going to just take off the formula, okay? I'm going to read out the question, okay, and we're going to try it on the board together, okay? So let's put example. Alright, so a gas sample is contained in a cylinder and it's equipped with a movable piston occupied at 300 milliliters. So this is the volume, so let's put given. So I'll put V1. So the volume will usually be given in milliliters, okay? You should convert it into liters before you put it in the formula. So I'm going to put divided by 1,000. So I have 0.3 liters, okay? And the pressure is given at 2 atm, which is 2 atmospheres. So I'm going to put 2 atm here, okay? And it's asking for what would be the final pressure if the volume is increased to 500 milliliters, okay? So the volume, V2, is increased to 500 milliliters. Again, we're going to divide this by 1,000, and I'm going to change it into liters, okay? So 0.5 liters, okay? So just like this, okay? And then at the same time, I like writing out what is given and as well as what is required, okay? Because the question is saying, what is the final pressure? So I know that I'm looking for P2 here, okay? So let's try writing out the formula. So P1V1 equals P2V2. And all you're going to do, make sure you're always writing out the formula first, okay? Before you actually plug in the values. So I have the pressure, so 2 times 0.3 equals P2, because I'm looking for P2, so we'll just write it out here, times V2, which is 0.5. Okay, does everyone see that? Okay, and you can see it's a simple equation. If you're really good at math, okay, you could just write your final answer at the end. What we're doing actually is just dividing it by 0.5, okay, on both sides. Okay, and the reason for that is so the 0.5 is canceling out. So we're doing 2 times 0.3 divided by 0.5, okay? And this is a P2 pressure. So let's write over here. We're getting 1.2 atm, okay, or 1.2 atmospheres. This is going to be your final pressure, okay? And make sure you're doing like a mental check here, okay? For Boyle's law, I can see that the pressure and the volume are inversely proportional to each other, okay? Which means if I'm increasing the pressure, the volume has to decrease, all right? So if you're looking over here, okay, I can see that the pressure is 2 atm, okay? But the volume started with 0.3, let's underline it. And then I can see that the volume for V2 increased, okay, let's put an arrow up, to 0.5, okay? And in that sense, I know that the pressure has to decrease for P2, okay? I started with 2 atm here, and the P2 pressure should be basically less than 2 atm, okay? Which it is in this case. I got 1.2 atmospheres for the final pressure. Okay, and that way when you do this mental check, I know that my answer is correct. Okay, are there any questions there? Good, let's try one more example here, okay? I'm going to just take this part off. Okay, let's write down what's given first in this question. So let me read it out loud. So a balloon contains 1.5 liters of air. So this is the volume. okay? And it is taken underwater. It's at 1 atm actually, so let's put P1, 1 atm. And it's taken underwater to a depth where the pressure is now 3 atm, okay? So this is pressure 2, 3 atm. Okay, so notice when you do, if you're someone who likes swimming, okay, swimming in the ocean or in the swimming pool, you notice as you swim much deeper underwater, the pressure does increase here, okay? So it increased to 3 atm and we're calculating the new volume of the balloon, okay? So basically I'm going to put required here. And the new volume is going to be V2, okay? So this is what I'm looking for, all right? And again, I'm just going to write out the formula, all right? And then we can plug it into the formula. So P1 V1 equals P2 V2, okay? Just like this. Okay, I have the pressure. Pressure 1 is 1 atm times 1.5 liters, okay? And it's equal to P2, which is 3 atm times V2. Okay, sometimes students get excited because the equation is just so simple, okay, that they actually kind of mix up some of the numbers that they're plugging into the formula. Okay, so make sure you are double checking here. All right, I'm looking for V2 this time, so I'm just going to divide this by 3. Okay, so we're doing 1.5 times 1 divided by 3. Okay, and we are getting the volume of V2 as 0.5 liters. Okay, so this is our final answer. So also make sure, because these are application questions, you are putting a concluding sentence at the end, okay? So it's saying calculate the new volume, okay, of the balloon. All right, and we can just write what the new volume is, okay? So therefore, I'm going to put the new volume, okay, everyone can see that, of the balloon. Okay, oh, that's already on this side. Okay, so the new volume of the balloon is, okay, and then just what we got here, so 0.5 liters. You should make sure even when you write liters, okay, that you are writing it out in words, because this is a final concluding statement here. Okay, so I hope everyone's okay with that question. All right, so with that, we're going to try this last example here, okay, and the temperature is going to be constant again. Okay, so let's take this out. All right, and just don't forget in terms of, okay, the volume here, okay, that you are, again, just changing the volume from milliliters into liters, okay? So I have a sample of krypton gas, okay, so let's put given. Sample of krypton gas is occupying 75 milliliters at 0.4 atm, okay? So I have 75 milliliters. I'm going to divide that by 1,000. Again, make sure you watch the number of zeros, especially if you're doing this mentally, okay? So 0.075, okay, in liters. And it's at 0.4 atm. So just like this, all right? And now the temperature is going to be constant here. And it says, what volume would the krypton occupy at 4 atm? Okay, so we'll put P2 is 4 atm. Okay, and notice for all of these questions, I have 4 variables. 3 variables have to be given to me, so I can actually solve for the unknown variable, okay? And we're looking for V2. What volume is it going to occupy now? Okay, and sometimes the teacher might try to trick you just the way the question is worded. You might have to look for maybe like the initial volume or the initial pressure, okay? So the teacher can ask you to solve for any of the variables, so just be ready for that. All right, so let's plug this into our equation. So P1 V1 equals P2 V2, okay? I'm going to plug in my pressure, so 0.4 times 0.075, okay? Equals, I can see the pressure is increasing here, 4 times V2, okay? And because I'm solving for V2 here, we're just going to divide it by 4 on both sides. Okay, and this 4 should be canceling out, okay? My final answer is for V2. Okay, so we're doing 0.4 times 0.075 divided by 4. Okay, so we're getting 0.0075, okay, in liters, all right? And if the question asks you, you can also convert this back into milliliters. So we'll just times it by 1,000 here. Okay? So remember to move the decimal place 3 times. So 1, 2, 3. It's going to be 7.5 milliliters. Okay, for the V2 volume. Okay? So just like this, okay? And again, you could just do that mental check, okay? I can see that we're starting off with 0.4 atm, and the pressure for P2 is increasing by quite a bit. And if the pressure is increasing by quite a bit, the volume has to decrease by that same amount almost, okay? So I'm going to put decrease in the volume, okay? And the volume as well, you can see we started with 0.075. And what we end up with is the 0.0075. Okay, or we started with 75 milliliters, okay, and we're ending up with 7.5 milliliters, okay? So because the volume for V2 decreased, I know that I have the correct answer as well, okay? So again, make sure you are doing that mental check, and it does tell you, like, for sure that, like, you have that right answer, okay? The amount that the pressure here is increasing by should be just about the same in terms of the volume and what it is decreasing by, okay? There's no need to get technical to find the exact values here, okay? But I would make sure I do that mental check, okay? Alright, so if there are no questions, that brings this video to an end. Thank you for watching. Please make sure you do like, share, and subscribe to the channel, and I will see everyone in the next video. Thanks, bye.